Welcome to Dynamics Part 2, Force and Momentum. And as you see on the screen, an alternate form of Newton's second law, F equals ma, is F, the force, is equal to the change in momentum divided by time. And keep in mind that both force and momentum are vector quantities. Now, because we normally work in a scalar world, we're most commonly going to use this form of the equation, which is a scalar version. And because momentum is nothing more than mass times velocity, and in our problems, the mass will be a constant, the change in momentum is really nothing more than a mass times a change in velocity. So an expression for that is this, where the force is equal to the mass, which is a constant, times V2 minus V1, which is delta V, divided by T. And a quick example. A driver needs to stop a 1,000 kilogram car from 20.0 meters per second in 5 seconds. Find the force needed. All right, this expression is the one we're going to use. Force is equal to mass, V2 minus V1 divided by T. Force is equal to the mass, 1,000 kilograms. V2 is 0 because we're coming to a stop. Minus 20 meters per second, which is V1. And we're told that it takes 5 seconds. Force is equal to minus 20,000 kilogram meters per second divided by 5 seconds. So the force is minus 4,000 kilogram meters per second squared. This is a Newton, so the force applied is minus 4,000 newtons. Now, the minus sign indicates that the force is in a direction opposite to motion, so it's a braking force. And we know this car is slowing down or decelerating from 20 to a stop. Makes perfect sense. Okay, example number 2. This one's going to be a little bit longer because it involves some bigger numbers. A ship with a mass of 4.0 times 10 to the 10th kilogram is slowed by the resistance of the water from 12.8 meters per second to a stop. So right away we know that the V2 is going to be 0. If the water supplies a braking force of 8.5 times 10 to the 8th newtons, find how long it takes to stop. Okay, so it's a little different. We're asking to find T instead of F. Give ourselves a little bit of room to write here. Force is equal to the mass, V2 minus V1 divided by T. The force applied is given, minus 8.5 times 10 to the 8th newtons, minus, because it's a braking or slowing force, the mass of the ship is 4.0 times 10 to the 10th kilograms. V2 is 0 because if a ship comes to a stop, that's given right up here. Initial velocity, 12.8 meters per second. And we're looking for the time it takes. This is our equation all set up. Now it becomes a math problem. time is equal to 4.0 times 10 to the 10th kilograms. Do the arithmetic right here. Minus 12.8 meters per second. And we're going to divide by braking force minus 8.5 times 10 to the 8th newtons. Now you're all capable of sticking this stuff into your calculator and pushing the equal sign. We find that the amount of time taken is 602.4 seconds. Notice the time is positive. We expect that. If the time was negative, that would indicate either we forgot a minus sign or performed a math error some ways along the line. So that's just a common sense check on what we're doing. Okay, I hope that helped. Please feel free to leave a comment. Let me know if this is clear, you need more examples, it's not clear, or anything else. Appreciate your time.